In this session, we'll be learning about higher order derivatives. Let's take the function fx is equals to sine square x, and we have to find the third order derivative, that is f triple dash of x. So let's see how can we do it. First order derivative will be 2 sine x into cos x. 2 sine x for sine square x and cos x for sine x. So 2 sine x cos x can be written as sine 2x. So we'll get sine 2x. Now if I differentiate it again, then I'll get f double dash x is equals to sine 2x derivative will be cos 2x. So cos 2x, and for 2x the derivative will be 2. So I'll get 2 cos 2x. Now again differentiating f double dash x, I'll get f triple dash x is equals to 2, and for cos 2x it will be minus sine 2x, and for 2x it will be 2. So finally I'll get minus 4 sine 2x as my third order derivative. I hope this one is clear to you. Now moving on to the next problem. So in this problem we are given with y equals to sine of sine x, and it is given that d2y by dx2 plus dy by dx into tan x plus fx is equals to 0, and we have to find the value for fx. So according to the equation, if I find these values, that is dy by dx and d2y by dx, then I can easily find the value for fx. So let's try to do it. Then dy by dx will be for sine of sine x. Then for sine of sine x it would be cos of sine x, and for sine x it would be cos x. Now this is the value for our dy by dx. Now differentiating this function again to get d2y by dx2, we'll have d2y by dx2 is equals to, these are multiplication of two functions, that is cos of sine x into cos x. So let us consider this as first function and this as second function, and we can use the product rule here to find the derivative. So derivative of first function will be minus sine of sine x into cos x for this sine x, and into cos x, that is our second function, plus first function as it is, and derivative for our second function will be minus of sine x. So we'll get minus sine of sine x into cos square x minus sine x into cos of sine x. So now I can easily put the values of d2y by dx2 and dy by dx in our equation. So I'll get, if I put the value of d2y by dx2 first, then I'll get minus sine of sine x into cos square x minus sine x into cos of sine x, plus dy by dx is cos of sine x into cos x multiplied by tan x plus fx is equals to 0. Now if here I put tan x equals to sine x by cos x, so sine x by cos x, then this cos x will cancel this cos x and I'll be left with sine x. So if I put the respective value, then I'll get minus sine of sine x into cos square x minus sine x cos of sine x plus cos of sin x into sin x plus fx equals to 0. Now sin x, cos of sin x and cos sin x and sin x will cancel each other and I'll be left with this term, and if I shift this term towards the right hand side, so I'll get fx is equals to sin of sin x cos square x as my value of fx. So we have got the value for fx by putting the values of dy by dx and d2y by dx too. I hope you are clear with the concept of higher order derivatives with this question.